Hello friends, I am Mrs. Sandhya Lanke from Sri Jain Vidya Prasarak Mandras, RASIKLAL M. Dhariwal College of Pharmacy, Pune. Here is another point from Pharmaceutical Chemistry 1, Antioxidants, which is mentioned in the syllabus of first year diploma in pharmacy. Let us discuss the learning outcomes of this topic. After watching this video, you will be able to define antioxidants. You will be able to list ideal properties of antioxidants and you will be able to explain mechanism of antioxidants. Now let's move further. Now before going for the exact topic antioxidants, we should know what is exactly the oxidation and reduction. So just take a minute and think on these 2 points, oxidation and reduction. You might be learning this in 11th as well as 12th standard. So oxidation is nothing but addition of oxygen, or we can say it as a removal of hydrogen, or in another words we can say it as loss of electrons. While reduction is addition of hydrogen, or we can say removal of oxygen, or in another words we can say it as gain of electrons. So oxidation and reduction, these two are the simultaneous type of chemical reaction, and when these two reactions are taking place, that particular reaction is also called as redox reaction, oxidation and reduction reaction. Now let us discuss the definition of antioxidants. So antioxidants are the agents which inhibit oxidation and are commonly used to prevent rancidity of oils and fats or deterioration of other materials like drugs through oxidative processes. In short, you might be knowing first, whenever such type of definitions are there, just split out the words. Antioxidants. Anti means against and oxidants nothing but the oxidation. So the agents which are used to prevent oxidation are called as antioxidant agent. Now you might be knowing that some of the oils and fatty substances, if they are preserved for longer duration of time, they undergo rancidity. Rancidity, it is nothing but the foul odor or bad smell of that particular product, and deterioration is nothing but the decomposition. The efficiency of that particular substance is totally lost. So just if we are not going to store these oily and fatty substances properly, that may undergo rancidity and deterioration. So as to prevent such type of conditions, we can use antioxidants. So antioxidants are mainly used to prevent rancidity of oils and fats, as well as they are used to prevent deterioration of some of the drug substances. Now let us discuss the classification of antioxidants. Antioxidants are mainly classified into two major classes, organic antioxidants and inorganic antioxidants. Organic antioxidants, for example, tocopherols, phenols, parabens, gallic acid, BHA, BHT. Now BHA, butylated hydroxyanisole, BHT, butylated hydroxytoluene. These are some of the examples of organic antioxidants. Inorganic antioxidants, for example, sulfur dioxide, nitrogen, hypophosphoric acid and sodium thiosulphate. In current syllabus, we will just discuss about the inorganic type of antioxidants. Now moving ahead with the mechanism of action of antioxidants. The mechanism of action of inorganic type of antioxidant is the same as it is involved in redox chemical reaction. Just only we have discussed what is redox chemical reaction. So what happens in redox reaction? There is transfer of electron from one compound to the other. Oxidation is loss of electron from one chemical species and reduction is gain of electron. So we can see here the overall reaction. In oxidation there is loss of electron and simultaneously the another species is getting that electron, nothing but the reduction process. So as I have told you, oxidation and reduction are the simultaneous processes, and same mechanism is involved here in case of the antioxidants. Moving ahead, when a substance acts as antioxidant, it gets oxidized itself and prevents the oxidation of active pharmaceutical species. So, how antioxidants are going to be act? They are themselves get oxidized and they prevent oxidation of the active pharmaceutical species. Then, if the active pharmaceutical species is already oxidized, then antioxidants will reduce it back to its original reduced form. In turn, it will prevent the oxidation. One example is given here. Inert nitrogen gas can act as antioxidants by preventing pharmaceutical preparation to come in contact with the oxygen. Now, mainly this inert nitrogen gas is blown in ampoules and vials in which parenteral solution is to be filled. At that time, this nitrogen gas will prevent the oxidation. Whenever that ampoule or vial is exposed to the atmospheric oxygen, it may carry out oxidation. And so as to prevent that oxidation, here nitrogen gas is used as an antioxidant. Now, let us discuss the different official antioxidants. In board exams, question can be asked for 2 marks. List out the official antioxidant preparations or antioxidant compounds. So here is the list: hypophosphorus acid, sulfur dioxide gas, sodium bisulfite, sodium metabisulfite, sodium thiosulfate, nitrogen gas and sodium nitrate. So among these 6 to 7 you can just enlist 4 to 5 for 2 marks. Now let us discuss the ideal characteristics of antioxidants. How an antioxidant agent should be. It should be non-toxic. It must be effective in low concentration. It should be palatable, as so many drug substances or dosage form are to be administered orally. In that case, antioxidant is needed. That's why the antioxidant should be palatable. It should be compatible with pharmaceutical products. Compatibility means what? This antioxidant should not react physically, chemically or therapeutically with the drug substance. Then it should be soluble in normal aqueous solution. It should give no color or odor to the product. It should be physically and chemically stable. It should be chemically inert, and it should not create solubility problem in its oxidized and reduced form. Now, so these are the ideal characteristics of antioxidants. Next one is the monograph of one of the drug, that is sodium thiosulfate. We have listed so many official compounds. So this is a representative from that. Sodium thiosulfate is having the molecular formula of Na2S2O3 5H2O with a molecular weight 248.2. The standard states that it should contain not less than 99% and not more than 101% of Na2S2O3 5H2O, nothing but sodium thiosulfate. Now moving to the next, that is physical properties of sodium thiosulfate. You people might be used it in practical, so you might be knowing the physical properties. It occurs as transparent colorless monoclinic prism or as a crystalline powder. It has cooling bitter taste. It effloresces in dry air and deliquesces in moist air. Now what is this deliquescence? Deliquescence is nothing but ability of that particular compound to absorb moisture from the environment in such a great extent that it get liquefied. So whenever the sodium thiosulfate is kept in the moist air, it may get deliquefied. Then regarding its solubility, it is soluble in water but insoluble in alcohol. Its aqueous solution decomposes in boiling because of reduction to sulfide and oxidation to sulfates. So always remember, physical properties should be correlated with that of the storage condition. Now let us discuss the uses of sodium thiosulfate. Sodium thiosulfate, it is used as an antioxidant, as we are discussing the same chapter. Then it is considered useful in parasitic skin diseases. Skin diseases because of some of the parasitic organisms. Then it is used in controlling the infection of athlete's foot. Now what is this athlete's foot? Sportsmen they are going to frequently use the shoes for longer duration of time, and there are chances of some of the fungal or bacterial infection, and that particular infection is called as athlete's foot infection. So this sodium thiosulfate is used to treat that infection of athlete's foot. Then it is effective in cyanide poisoning as an antidote. In combination with sodium nitrite, this sodium thiosulfate is useful as an antidote. And lastly, sodium thiosulfate when used in large doses causes cathartic action. That means it is used to increase the bowel movement. So these are some of the uses of sodium thiosulfate. And the last one is the storage and incompatibility. Its alkaline solutions are stable, and so if it is stored, sufficient amount of sodium carbonate or borax is added to make it stable. Actually, the alkaline solutions of sodium thiosulfate are stable one, but we can add sufficient amount of sodium carbonate or borax to make it more stable. And as it discussed in physical properties, this compound has ability to cause deliquescence. That's why it should be stored in airtight container so that it will not come in contact with the air. Incompatibility. This compound is incompatible with salts of heavy metals, oxidizing agents and acids. That means this compound has ability to react physically, chemically or therapeutically with all these listed substances. Whenever this substance is saturated with oxidizing agents like chlorates, nitrates and permanganates, there are chances of explosion. So while mixing these compounds, we have to take precaution. So this is all about the monograph of sodium thiosulfate. Likewise, you can study the monograph of all the official compounds which act as antioxidants, which we have discussed previously, like hypophosphorus acid, nitrogen gas, sulfur dioxide gas, sodium metabisulfite, likewise. So thank you for watching this video. Thank you very much.